Okay, welcome back to part 2. Question 7. So we've got Gwen fills a 10-litre bucket with water from a tap. She turns the tap until it fully fills the bucket. When she thinks it's close to being full, she slowly closes the tap. The bucket is full after 20 seconds. Graph shows the volume of the water in the bucket during the 20 seconds. After how many seconds did she stop closing the tap? Well, you can see, just use hello. You can see she didn't open the tap much there. Then it was shot up and she slowly stopped here. So I'm going to say approximately here. So I'm just going to read down and I'm about there. So I think each one is 2, isn't it? So we've got 5, 6, 7, 8, 9 seconds. So after 9 seconds, she roughly stopped. She started to close it. Estimated water rate water is entering the bucket at time t10. Give your answer in litres per second. So this is basically you want to see at what is accelerating and deaccelerating at 10 seconds, really. So this is where we need to draw a tangent to our curve. And then we need to pick 2 points on our line and do our change in y over change in x. So I'm just going to pick literally the point at 10, because obviously that's going to be on 10. And I'm going to pick round about here. So I'm going to read across, that's going to be 10. I think that's directly on 9 there. So I can see that my change in y over change in x. So my change in y difference between 9 and 10 is 1. And let's see my difference in x's. So we've definitely got 10. And I think that's about 13, maybe-ish. If you guys make us, that's fine. So not 1 over 13. What am I doing? Difference between 10 and 13 is 3. Not 13. So that's 0.3 recurring. Per time, or are we doing volume per litres? Per litres second squared. So litres per second, so it should be L per S squared. Because litres per second squared. Okay, question 2. When the tap is fully open, the water flows out at 2 litres per second. Express 2 litres per second in gallons per minute. Where are they? So they've given you the gallons to pints. You need to know them. How many litres are in a gallon. Because there's 4.5 litres in a gallon. Or you could do litres to pints and then pints to gallons. It's up to you, really, what you do. Because I don't know why they've given it to us, but okay. I'll do it to pints then. So you should know that 1 litre is 1.75 pints. So if 1 litre is 1.7 pints, then 2 litres, because we've got 2 litres, just double it, is 3.5 pints. We want the gallons to pints now. So we're basically 3.5 is 8 pints in 1. We divide that by 8. And we get 0.437 gallons. This is still per second though. So this is still per second. And we just need to change that into minutes. We should know how many seconds are in a minute. Just times it by 60. Why is it not letting me write? Times it by 60. And you should get 26.25 gallons per minute. That's a horrible one, really. Can a fully open tap fill a 90-gallon tank in under 3.5 minutes? Well, whatever your answer for this one is, you might get this one right or wrong. So 26.5 gallons in 1 minute. Well, times that by 3.5 minutes, and you get 91.875. So in 3.5 minutes, it can fill 91.8. So yeah, it's going to fill a 90-gallon tank then, isn't it? If we can do 91.875. Okay, so question 8. The head teacher of Uskall Castle, Gwyn, wants to display pictures drawn by pupils along one side of a corridor. The pictures are to be in one row with no gaps between them as shown in the diagram. Pictures are all squares with side length of 15, correct to nearest 0.5 centimetres. The length of corridor wall is 2010 centimetres, correct to nearest 10 centimetres. Calculate the smallest number and the greatest number of pictures that can be fitted. So this is all about upper and lower bounds. So if we first do the picture, so this is 15 centimetres, correct to the nearest half centimetre. So I'm just going to do the upper and lower bound. So the upper bound and the lower bound. So to do the upper and lower bound, you take wherever it's rounded to, half it, so 0.25, For the upper bound, we add it on. So 15 add 0.25 is 15.25. And for our lower bound, we take it away. So 15 take away 0.25 is 14.75. So we're going to use those in a minute. Are we doing hallway? Corridor? Corridor. So the corridor's upper bound and lower bound. We've got, it's 2010, correct to nearest 10. So we take our bound, we half it, so that's 5. Upper one, we add it on, so 2015. And for the lower one, we take it away, so 2005. So to get our smallest number of pictures, so we want the smallest corridor with the biggest pictures. So we want the lower bound and the upper bound. So we want to do 2005 centimetres divided by 15.25 will give us our lowest number of 131. For the greatest, we want the biggest corridor and our lowest picture. So the biggest corridor, our smallest picture, will get the most in. So that is 2015 divided by 14.25 is 136. Put it in the box. So smallest, 131, 136. Blank page. Okay, circle either true or false for the statement given. A nominal annual interest rate is not the same as AER. Well, no, you use nominal annual interest rate to calculate AER. AER is going to be yearly. Nominal interest rate can be any time. It can be monthly, it can be daily. It could also be yearly, but they're not the same. So that is true. A savings account offers a nominal interest rate of 2% with interest paid monthly. After a year, any investments will increase by the value of 2% exactly. No, because if it's paid monthly, then after a year, it's not going to raise by 2%, is it? A savings account offers an AER of 2.4% with interest paid monthly. The monthly interest rate of the account offers will be exactly 0.2%. No, not really, no. Because you put that to the power of 12, so it's not going to be. £100 is in a savings account that pays monthly interest rate at 1%. There is no further transactions in or out of the account. The account will be the account after a year will be £112. No, so interest rate of 1% paid monthly, you can't just do 1%, is going to be 1 each time because you want 1% of £100, add it on. 1% of the new figure, add it on. 1% of the new figure, add it on. So no, it's not just going to be 112. I could work those out, but I'm not going to. Benjamin invests £1,000 into an account that pays interest every 6 months. He does not take any further payments into the account and does not withdraw any money. After a year, there is £1,036 in the account. Calculate how much was the account after 6 months. Give your answer to correct to the nearest penny. So this is like compound interest. So compound interest, we would take our amount, we would times it by our percentage, which we don't have. Because it's paid every 6 months, that's to the power of 2, and we got 1,036. We're basically looking for our percentage or our decimal. So we can first divide by 1,000. So our percentage to the power of 2 is 1,036 over 1,000. And then, so just our percentage would be the square root of whatever that is, 136 over 1,000. We should get the percentage then being 1.017. So that's how much it would be after just the 1 year. After the 6 months. So all you need to do is do 1,000 times that answer, 1.017, not to the power of 2 because you only want it once, and obviously you get £1,017. I think you do get 84 pence as well. I didn't include that in my decimals, but you do. Question numero 10. A company makes plastic shelf supports for use in kitchen cupboards. That doesn't look like it should be in a kitchen cupboard. The shelf support is made by attaching a cylinder to a right-angled triangular prism. The cylinder has a diameter of 6. I'm going to draw this on here. 6. The length of 9. So that length there is 9. Have we got to do surface area or volume or something? Yeah, it says volume later on. Okay. Prism has dimensions CD is 8, so that is 8. DE is also 8. And CE is 11.3. Interesting. And BC is 10. The cylinder, we've just read that. Company sells the shelf supports packs of 500. It needs to know that the volume of plastics in 500 shelf support. Calculate the volume of the 500 shelf support. Okay, I'm going to do the volume of the cylinder first. So the volume of a cylinder is the area of the face. So pi times our radius, which is 3, not 6. Squared, and then you've got to do area of the face times its length, so 9. So I got 254.5. Then the volume of the prism Again, you just do the area of the face. So that's going to be a half base, which is 8, times height, which is also 8. And then you want to also times that by the length, which is 10. I got 320. So the total volume, you need to add those together. So 254.5 add 320 is 574.5. And this is what we're in millimeters cubed, because we're in volume. And they want a pack of 500, just times that by 500, and we get 287,250. Lovely. Part B. The company also makes metal door handles for kitchen cupboards. One of the door handles is shown below. It's formed by joining 2 cylinders. One of the cylinders has a diameter of 4, length of 1.2, that's on there. The other cylinder has a diameter of 1.8, that's on there, and the length of 3, that's also on the picture. It's not a lot of room. Oh, I don't want to flip back and forth. Maybe I can just take this. I'm just going to take this over to the other side. And what we're going to do, we want to calculate percentage in the reduction of the surface areas, because they're not painting part of it. Okay, so got lots of space in there. We want the area of all the faces. So we've got that face at the front, I'm going to call that A. We've got this face here, that's B. I'm going to call this face C, this face D, and this face that we're not going to paint anymore is E. So I'm going to do the area, the surface area of all the faces. So face A is just an area of a circle, so pi times the radius, diameter is 4, so radius is 2 squared, which is 12.6. For B, so to do this one, it's basically like if you stretched out a rectangle, so you know it's 1.2, one side, and that length is just going to be the circumference of your circle. So that's pi times your diameter, which is 4. So you go to 1.2 times 4 times pi, which is 15.1. For shape C, you've got the circle, which we just did, so 12.6. We want to take away that little circle at the front, so basically E. So we want to take away pi times the radius, which is 0.9 squared, which is, let me just round that. I'm doing them all to one decimal place, but that rounds to 10. So for shape D, again, just like the B, you're going to do the length, so 3 times the circumference of that little circle here, so this length here, which is pi times the diameter. What am I doing? Ignore that. Pi times our diameter, which is, what did I get? 17. And then for E, which we're going to remove later on, I'm not going to paint that anymore. Area of the face, pi times the radius, so 0.9 squared, which is 2.5. So we used to do all of them. We used to do A plus B plus C plus D plus E, which is 57.2. But now we're just doing A plus B plus C plus D, just those, which is 54.7. We want the percentage in the reduction, so the difference was just that 2.5 over the original, which is 57.2. Hang on. 2.5 divided by 57.2 is 4.4. I'm going to round to percent. So just divide them and then times by 100 if you're struggling on how to do percentages. So the change divided by the original, and that's it for that question. Question 11. A sensor can detect any movement up to a distance of 6.5 meters. The storeroom is in the shape of a cube. Oh, this looks like 3D. So it's A is directly at B, which is 2 meters. Okay, in front of that is 20 centimeters. AB. Okay, that line there is, oh no, this gap here is 20 centimetres. Oh, I see, I thought the whole line was 20 centimetres then. That wouldn't make any sense. What do we have to find out? Will the sensor be able to detect movement at B? So we've got to calculate the length of this line. So we already know it's 20 centimetres, so don't forget to take 20 centimetres off your answer. So we just got to calculate that line. So to do that, you can use 3D Pythagoras, and so I first want to find out the length of BE, because then we've got this nice triangle, because that's 3.2 there. So in order to find this one, we're going to need this length here, BE. So to do BE, we can see that this is 5.5 and 2, so we know that's the hypotenuse. So I can do 2 squared plus 5.5 squared, and then that is 34.25. Square root that, and I get 5.85 5 meters. I shouldn't lay it out like that, but I don't want to go on to the other side. So I've got this as 5.85 meters. Now I can calculate the length AB. So the length of AB, we're going to ignore that 20 centimeters for a minute, is 5.85 squared plus the 3.2 squared, which is 44.46. Take the square root, which is 6.67 meters. But don't forget, we got already, it's gone out by 20 centimeters. This is in meters, so centimeters is 0.2. So take away 0.2, and we get 6.47. What did it say it had to be? It can detect movement at 6.5. Oh, it just about does it. So yes, it's fine. If you want to write a conclusion, that's fine. Is there another bit? Okay, show that BAE is 61.3, correct to the nearest one decimal. B to A to E. So from B to A to E. Okay. So we got this angle here that we're trying to find. I'm just going to redraw it. So we've got this triangle. Got this triangle, and we've got to find that angle. I'm just going to redraw it over the other side. So we had this length was 5. No, that length was, well, we just worked out 6.47. 6.47. That length is 3.2. That length, what's that bottom one? 5.85. 0.85. Still, it is still the right angle, but we got to try and find out that angle. So you can use any angles again. I'm just going to use these two by side. So I'm going to use adjacent and opposite. So SOHCAHTOA again. So O and A is tan. So tan of my angle, which I do not have, what should we call it? Call it X, is opposite. So 5.85 over the adjacent 3.2. So tan X, finding an angle, we've got shift tan. So tan to the -1 of whatever that is. I'm just going to leave it in a fraction. And I got 61.3. So proved. End of paper. Goodbye. Don't forget to hit the like button.